Hello everyone, Shema El-Shafai here. Today, we're delving into two of the most crucial pillars for successfully adopting AI in integrated water resources management, governance, and policy frameworks. Think of these as the essential blueprints for ensuring AI is used responsibly, transparently, and effectively to manage our most precious resource, water. Let's get started. Pillar 1. Governance. What does that even mean? Governance refers to the set of rules, practices, and institutions that guide how AI is used in integrated water resources management. Good governance isn't just bureaucratic red tape. It's what builds trust and ensures that AI is used responsibly, transparently, and in the public interest. There are 4 key aspects to consider. First, data governance. AI is only as good as the data it's trained on. We need to ensure our data is accurate, complete, and unbiased. This means establishing robust frameworks to manage data quality, security, and who gets to access it. Second is algorithmic transparency. We can't just have a black box making critical decisions about our water. We need to understand how AI algorithms work, and being able to explain their decisions is vital for trust and accountability. Transparency in AI decision-making processes should be clear and understandable, right? We can do this by using techniques that help us explain how models work and why they make certain choices. Third, stakeholder engagement. We need everyone at the table: citizens, farmers, industry leaders, and policymakers. Involving all stakeholders in the decision-making process builds trust and ensures the AI solutions we create actually meet the real-world needs of the community. And finally, fourth, accountability and oversight. We need clear lines of responsibility. If an AI system makes errors or shows bias, we need to know who is accountable and have mechanisms in place to correct it before it causes significant consequences. Of course, implementing good governance isn't easy. It's a delicate balance between innovation, integrity, and impact, where ideals meet reality and responsibility is truly tested. We face some major challenges. For instance, water data quality and availability are often a mess, fragmented, incomplete, or inconsistent. This makes it tough for AI to produce reliable results. Plus, water systems themselves are incredibly complex, with intertwined hydrological, social, and economic factors. It's a real challenge to build AI models that can accurately capture all of that. Then there's the problem of getting different systems to talk to each other. Integrated water resources management involves so many different organizations and technologies. AI solutions need to be compatible and integrate smoothly with what's already there. AI models can also be opaque, making it difficult to understand their decision-making processes. This lack of transparency can erode trust in AI-driven integrated water resources management decisions. So, integrated water resources management must be adaptable to changing conditions, including climate change, population growth, and technological advancements. AI solutions must be able to scale and adapt to these changing requirements. Beyond these challenges, there are real risks we need to manage. AI models can inadvertently learn and amplify existing biases, resulting in unfair water distribution and social injustice. And let's not forget cybersecurity. AI-powered water systems can be vulnerable to attacks, which could potentially disrupt critical water structures and infrastructure. Over-reliance on technology can also be a risk, making us less able to intervene if an AI system fails to perform as expected. After exploring the general AI risks in integrated water resources management, such as bias, cybersecurity threats, and overdependence on technology, we move to another critical dimension: AI governance risks. These aren't about the technology itself, but about the systems and structures that are supposed to guide and control how AI in integrated water resources management is used. And when those systems are weak, even the best AI tools can fail to serve the public good. Let's take a closer look. The first governance risk is the lack of regulation. Imagine an AI model deciding when to release water from a dam, but there are no clear legal rules defining accountability if something goes wrong. When development outpaces regulation, AI may be deployed without ethical oversight, leading to ungoverned and potentially harmful decisions that affect entire communities. The second governance risk is inadequate standards. Without consistent standards for how AI is designed, tested, and implemented, each project might follow its own rules, or worse, no rules at all. That means one AI system could interpret water demand differently from another, producing inconsistent or unreliable results. In a field as critical as water resources, inconsistency isn't just a technical flaw. It's a governance failure that can impact livelihoods and ecosystems. The third governance risk is insufficient public engagement. AI decisions can shape who gets water, when, and how much. Yet in many cases, the people most affected, citizens, farmers, and local communities, are not included in the conversation. When the public is left out, trust erodes. Even the most advanced AI solutions can face resistance, not because the technology is bad, but because people feel excluded from the process. So, while AI offers powerful tools for smarter and more sustainable water management, governance risks arise without strong regulations, clear standards, and genuine public engagement. Without these, AI can drift from progress to mistrust, which reminds us of a vital truth: technology alone is not enough. So, how do we tackle this? We need a comprehensive AI governance framework. This means establishing clear guidelines and regulations, demanding transparency from our AI models, and truly engaging with the public. It also means investing in training and capacity building, so we have the skills to use AI effectively. And finally, we must continuously monitor and evaluate these systems to catch and fix issues early on. By facing these challenges and risks head-on, we can ensure AI becomes a powerful and responsible tool for sustainable, integrated water resources management. Now for our second pillar, policy frameworks. If governance provides the rules of the road, policy frameworks are the national highway system that enables the journey. They provide the guidance and support needed to bring AI into the mainstream of integrated water resources management. An effective policy should first encourage innovation. We want to create an environment where new AI technologies can be developed and tested, but always with responsible use in mind. Second, policies must address regulatory gaps. Our current laws on data protection, liability, and intellectual property probably weren't written with AI in mind. Policies need to be updated to provide clarity and guidance in this new landscape. Third, policy must support capacity building. We need to fund training programs to equip our water professionals with the skills to develop, use, and oversee AI solutions. It's about building a workforce ready for the future. And fourth, policy should foster collaboration. Policies should encourage partnerships between government agencies, the private sector, academic institutions, and civil society to pool resources and expertise. These policy frameworks need to be specific. They should mandate clear rules for data governance, ensuring data is collected and used ethically. They must require transparency and explainability in AI systems. They need to include measures to identify and mitigate bias to ensure fairness. They have to establish clear lines of accountability for AI-driven decisions. And critically, they must enforce robust security standards to protect our water structures and infrastructure from cyber threats. When we get this right, the benefits are enormous. Strong policies build public trust, they create a stable environment that actually encourages innovation, and they help organizations comply with important environmental and data protection regulations. But it's a dynamic process. AI is evolving at lightning speed, so our policies can't be static. They must be adaptable. The key is finding that right balance, creating rules that protect the public without stifling the innovation we need. And because water often crosses borders, international cooperation on these policies will be essential. So, to wrap it all up, adopting AI in integrated water resources management isn't just about new technology. It's about building a solid foundation of robust governance and smart policy frameworks. These two pillars ensure that AI improves our decision-making, increases transparency, and builds public trust. Ultimately, they empower us to manage our water more effectively, optimizing allocation, predicting shortages, and mitigating flood risks. By getting the governance and policy right, we can unlock the full potential of AI to create a smarter, more sustainable integrated water resources management future for everyone. If you found this video useful, like, share, subscribe. Artificial Intelligence for Water AIW. See you in the next video.